When the neurotransmitters arrive at the postsynaptic neuron, it needs to activate its receptors. Some drugs can directly block the receptors. For example, some antipsychotic drugs like haloperidol will block dopamine D2 receptors. Once the receptors are blocked, dopamine will not function anymore. And that's how it can reduce the psychotic symptoms. Another drug, curare, also known as the arrowhead drug, blocks the nicotinic acetylcholine receptors. The function of acetylcholine is to make the muscles contract. Once the arrowhead poison is applied, acetylcholine receptors are blocked, and therefore the muscles cannot contract, and the animal is paralyzed. Some drugs will activate the receptors of the original neurotransmitter. For example, LSD is a very potent drug. It is a serotonin agonist, meaning that it will mimic the effect of serotonin. It will stimulate the serotonergic neurons inside the visual cortex, and the stimulation will last super long. As a result, the person would have strange visual hallucination. These are 4 drawings by the same person, and the model is also the same person. After taking LSD, their drawing changed dramatically, reflecting the change in their perception. This is the father of LSD, Albert Hofmann. He discovered LSD in 1943 and devoted the rest of his career studying it. LSD is a prohibited drug in most jurisdictions. It is distributed on colorful blotting paper. And this piece of art is made up of 1,036 individual doses of LSD. It depicts Albert Hofmann and also the LSD molecule. Sometimes the drug may change the metabolism in the postsynaptic cell. An example is alcohol. When you don't drink alcohol, the GABA system, which is inhibitory, and the glutamate system, which is excitatory, will be at a balance inside your brain. After you have taken alcohol occasionally, alcohol is going to increase GABA function and decrease glutamate function. So the inhibitory system in your brain is dominant. But after long-term use of alcohol, your body will go back to a new balance. To achieve this, the GABA receptors will be downregulated and the glutamate receptors will be upregulated. And downregulate means that there will be less such receptors, so that the neurotransmitter will have less effect. And upregulate is the opposite. Once your body is used to this new balance, if you suddenly stop using alcohol, because your glutamate receptor is already upregulated and GABA receptor is downregulated, your body cannot adjust to this new situation without the effect of alcohol. And that's why people would have the withdrawal symptom. The reuptake of neurotransmitters can also be blocked. Once the reuptake is blocked, the neurotransmitter is going to stay in the synapse for longer and they will have a prolonged effect. For example, cocaine would block the dopamine reuptake, producing a perception of prolonged pleasure. Ritalin also blocks dopamine reuptake, but it is in a more controlled manner. This drug is often prescribed for people with ADD, and fluoxetine can block the reuptake of serotonin, and it can be used as an antidepressant. The last step is to degrade the neurotransmitter by enzymes. And this step can also be disrupted by some drugs. For example, serotonin is a type of monoamine neurotransmitter. It will be degraded by the monoamine oxidase. The monoamine oxidase inhibitors have been used to treat depression, but it has a lot of side effects and it is becoming less popular. We have already seen earlier that acetylcholine esterase is used to break down acetylcholine in synaptic cleft. The nerve gases or the insecticides are irreversible inhibitors of the acetylcholine esterase, but there can also be reversible inhibitors. For example, donepezil is used in the treatment of Alzheimer's disease. It can temporarily extend the effect of acetylcholine on the postsynaptic neuron. And neostigmine is used in treating a disease with weak muscles. And we know that acetylcholine works in neuromuscular junctions. In the case of weak muscles, if the effect of acetylcholine can be prolonged, it will help the muscles to better contract. Some drugs will affect multiple steps in the neurotransmitter's life cycle. For example, amphetamine. Amphetamine is a synthetic psychostimulant, and it has a more potent relative called methamphetamine, also known as meth or speed. It closely resembles the monoamine neurotransmitters, and it can produce multiple effects. First, it can induce the release of neurotransmitters in the presynaptic nerve even without an action potential. And when the action potential arrives, it is going to facilitate even more release of the neurotransmitter. And also, it can block the reuptake transmitter, making the neurotransmitters stay in the synaptic cleft for longer. And finally, it can inhibit the monoamine oxidase, which means the neurotransmitters won't be broken down. All of these effects help to keep stimulating the postsynaptic neuron, and the person's function and behavior is going to be strongly affected. It's very easy to develop tolerance or addiction towards amphetamine or methamphetamine. Taking these drugs can lead to symptoms like sleepiness, weight loss, or motor disorders, cognitive impairment, and rapid changes in appearance. These two photos are taken just 2.5 years apart for a person with methamphetamine abuse. In general, the study of how the drugs can affect us at the cellular, molecular, or behavioral level is called neuropharmacology. The defective neurotransmission is often the root cause of many neurological and psychiatric disorders. But at the same time, please also remember what we have learned from the last lesson, the human connectome. Our brain is not just a bag of random chemicals. All the chemicals are connected in a complex way, and they will influence each other and interact with each other. So now that we have learned the process of neurotransmission, please try to apply that knowledge to your daily life and think about how your daily behavior can be explained by these cellular or molecular activities. And that would be the end goal of this course. To conclude, let me show you a few more videos. The first one explains how caffeine works. The two other videos are TED Talks, and they're a bit longer. The first one is about the bias in publishing positive results versus negative results. It reminds us to be critical and be conscious about these biases when reading research publications. And the third video introduces the research on targeted medication. It is going to work more efficiently and it will avoid side effects. I hope you find some of these interesting and helpful.